Hey Grady, here's question 2 of your engineering drawing. This is the one that you were talking about with the funky block and the 30-degree friction angle and how to handle that and how you're supposed to find the normal force, applied force, and everything. So just like the last one, you're right, the only one we know is we know how much this block weighs, and that happens to be the 500 newtons. So the first thing you do is you draw a line straight down to represent the 500 newton vector. Now the other vector, which is the applied force right here, goes at a 45-degree angle. So all I did was I just drew a line from the tip of the gravity vector to go straight over at a 45-degree angle. I didn't know how long it was going to be, so I just kind of extended it to as long as I wanted it to be. Now the trickier one is trying to figure out how to do this friction force and friction angle thing. The normal force and the friction force is at a 30-degree angle. That's what it means, that your friction angle is 30 degrees. And so all I did was I took a line, and from the tail of the gravity vector, I drew a line that was, and this is the angle, it's 30 degrees, at a 30-degree angle going down this way. Okay? Now, once I drew that 30-degree angle going down that way, again, I looked for that intersection point. This vector, or this line, actually represents the sum of the normal force and the friction force together when I add the two vectors together, kind of like how I showed it down here. Anyway, so you have a couple of choices. You can either show the gravity vector, the applied vector, and then the joint force normal and force friction vector, or you can do what I did, draw your gravity, your applied, and then draw your normal and your friction force separately. Now, once you kind of find all that and find out where they intersect, that is that equilibrium point. In other words, when the system is just about to start moving but not quite, you would go then take a ruler and you would measure that length of that applied force. And multiply it by the scale. In my case, my scale was 1 inch. It's 100 newtons. I came over here. I measured this to be 2 5/8 of an inch. Once I converted that to inches and then multiplied it by 100, I found that my normal force was 262.5 newtons. So anyway, that's how you do it. Okay? Hopefully that makes sense. Let me know if it doesn't. Talk to you later. Bye.